So we're going to do intro to triangles. What is a triangle? A three-sided figure. Now that's not a good definition. That's a bad definition. We need to write a better definition for this. A triangle is a figure formed by three segments joining three non-collinear points. So non-collinear points means they're not on the same line. So they are on different lines and you connect them and they are line segments, and that is those form a triangle. So how can I classify named triangles? Classification by size. If you have equilateral triangles, has three congruent sides. If you have isosceles triangle, you have two congruent sides. Scalene is triangle with no congruent sides. So you can have three types of triangle with classified by size. Equilateral, all three congruent sides. Isosceles. So isosceles, look, you have two eyes, so that's how I remember two congruent sides. And scalene is no congruent side, means all three sides are different lengths. If you classify triangles by angles, acute triangle has three acute angles. So each angle is less than 90 degrees. Equal angular means it's like equilateral but equal angular because means three congruent angles. So it has to be 60, 60, 60 because triangle has 180 inside. So they are 60, 60, 60 degree angle. And then right triangle has one right angle, which we know is 90 degrees. Obtuse triangle has one obtuse angle, which is over 90, less than 180. So here are four types of angles, triangles, classify angles. Acute, equiangular, means angle, like equal angle, 60, 60, 60. Right triangle and obtuse triangle. Classify angles, both sides and angles. So here, when you have 60, 60, 60, we call that equal angular by angles. And then if you have same size, if you see this mark, can you make a mark on your paper? These three marks, it shows that they are equilateral. So this triangle is equilateral and equiangular. Please make a mark here, two lines and two lines. That means isosceles by side. And then you have 46, 46. So that is, and then 88. So you're going to look at this angle. All three of them are acute angles. So they are acute triangle. So if you classify this triangle by size, it's isosceles. If you classify this triangle by angles, it's acute triangle. So parts of an angle. All triangles have vertex, adjacent sides, and then you have a right and isosceles triangle has legs and hypotenuse, base. Okay. So right here, all triangle has vertex and adjacent sides. So BC is adjacent to BA. CA is adjacent to AB. Those are adjacent. But right triangle and isosceles triangle has legs. So right here, this is right triangle. Leg, the right angle is there. The side that is right across from 90 degrees, the longest side, the slanted side, we call this hypotenuse. It's always across from 90 degree angle. And then for isosceles, we say this is the base, and then you have a leg and a leg. These two are congruent. So isosceles triangle has a base and then two congruent legs. So you have like a weird picture here. We're going to classify a triangle NMNO. You see this little triangle right there by sides and angles. So I know it's hard to see, but this side is 16, this side is 16. When you have two congruent sides and a right triangle, side angle side, like right triangle in the middle, we call this isosceles right triangle. And then where are the legs? The legs are here, here, and here. So side ON and side MN, those are your legs. Hypotenuse is right across from 90, which is MO. That's hypotenuse right here. And then base is OM also. The base is also OM. So here the hypotenuse and base is actually the same. So let's look at examples. Why is this triangle scaling? Scaling right. And why doesn't it have a base? So right here, this triangle right here is triangle 6, 8, and 10. So scaling right means you have a right angle, but all sides are different lengths. So we call this scaling right triangle. And it does not have any base here because it's not isosceles. Isosceles have base. Angles in a triangle. Interior are angles formed inside the triangle. Exterior is angles formed outside of the triangle. So right here you have two triangles ABC. Here inside, those are interior angles for the triangle. The angles outside right here are called exterior angles. So please copy interior and exterior under the diagram. So we need to know these theorems, okay? First theorem we need to know is triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180. Exterior angles theorem. The measure of an exterior angle of a triangle is equal to the sum of the measure of two non-adjacent interior angles. So triangle sum theorem is when you add all three angles, it's 180. The exterior means outside angle. So something like this. These are the exterior angles right here. The measure of an exterior angle of a triangle is equal to the sum of the measure of two non-adjacent interior angles. So I'm going to explain that on the next diagram. So justification for exterior angles theorem is when you have a triangle like this, you have 1, 2, 3, which is interior angles, and then anything outside of those is exterior angles, okay? So if I add angle 1, 2, 3 inside, those are 180. That is the triangle sum theorem, okay? Now, if I add angle 3 and angle 4, that is 180. These are called linear pair, okay? Now, if I add angle 1, 2, like right here, okay? So, right here, 1 and 2, these two angles, it's gonna equal angle 4. So, it's going to equal the ones that is not adjacent. What I'm saying is, if you look at the theorem, it says the measure of an exterior angle of a triangle is equal to sum of the measure of two non-adjacent interior angle. So non-adjacent means this right here, angle 4, angle 3 is adjacent to angle 4, right? So angle 4 is actually equal to angle 1 and 2. That is not next to this. Angle 1 and 2 is not next to it. These are the interior angles. So if you add the other two interior angle that is not adjacent to 4, angle 1 plus angle 2 is equal to angle 4. Why is that? Because angle 1, 2, 3 is equal to 180. 180 minus 3 will be 4, right? So this is 180 minus 3 will be 4 because this is a linear pair. That means if I do 180 minus 1 and 2, right, that is going to be 3. So if I do 180 minus 3, it's 1 and 2. So angle 1 plus 2 plus 3 is 180. Angle 3 and 4 is 180. Therefore, angle 3 and angle 3 is equal to each other. That means angle 1 and 2 is, if you add these two, is equal to 4. So what I'm saying is, if this is 30, right? Then 180 minus 30 was 150, correct? If this is 30, then if I subtract 180 minus 30, then this is gonna be 150. So angle 1 plus angle 2 will be 150, because 150 plus 30 will be 180 inside, right? So angle 4 is equal to angle 1 plus 2. So angle 4 is 150, angle 1 plus 2 is 150. So we're gonna have a new term. It's called corollary. It is a vocab. It sounds kind of odd, but it's called a corollary. Means a statement that can be proved easily using the theorem. So corollary to the triangle sum, the acute angles of a triangle of a right triangles are complementary. So corollary to this the triangle sum means it's a statement. So corollary means a statement that can be proved by using a theorem. Okay, so here you have a triangle, and then we're going to use a given. This is kind of like cut out, but the given is angle 1 is a right triangle. That is a given. We're gonna prove that angle 2 and 3 are complementary. Okay, so let's do the proof. Let's make a T-chart and then write statement and reason. Okay, so what we're going to do is write number 1. Angle 1 is a right angle, which is number 1 given. Then number 2, measure angle 1 is 90. That's definition of right angle. Angle 1, 2, 3 is 180. So sum of triangle sum theorem, which is what we just used. We just learned. And then 90 plus angle 2, angle 3 is 180. So I just substitute 90 into angle 1. Then angle 2 plus angle 3 is 90, because if I subtract 90 on each side, that's a subtraction property of equality, then I get 90. Then angle 2 plus angle 3 are 90, so therefore angle 2 and angle 3 are complementary. So that's definition of complementary. So please draw this and then write the proof. So we're going to look at this shape right here. We're going to use exterior angle theorem. So right here you have x, 72, and 2x minus 11. Find x. So right here we know that when you add 72 plus x, it's gonna equal this exterior angle non-adjacent 2x minus 11. So I want you to write x plus 72 is equal to 2x minus 11. You can solve for x by using algebra. You're going to add 11 and then subtract 1, so x equals 83. So if x equals 83, plug in here, and then you're going to plug in here. So if I do 2 times 83 minus 11, I get 155. So this angle is 155. These two are 155. 83 plus 272 is 155. So these two angles equal this exterior angle. This is exterior angle theorem. So we're going to use right triangle and find the measure of one acute angle is 1/4 of the measure of the other acute angle, and then we're going to find both measures. So I want you to draw a triangle like here on your paper and make 90-degree angle, which says right triangle, and then I want you to make one of the angles x, and then the other angle is 1/4 of that. Okay, so 1/4 x. When you add these three, it's 180. Now because it's 90, you can say these two angles, the sum will be 90, because 180 minus 90 is 90. So we're going to do x plus 1 for x equals 90. x plus 1 for x is 5 over 4x equals 90 because 1 is 5 over 5. And then you're going to divide 90 divided by 5 over 4, which is on the calculator, which is 72. So 72 is the x, and 1/4 of 72 is 18. So this is 18, this is 72, altogether 90. Let's do one below. The measure of the one acute angle is 5 times the measure of the other acute angle. Find each measure. Pause the video and try it and check with the answer key.